This bar graph shows, on average, how much local people felt that certain factors were to blame for the flooding. As you can see, heavy rain is the factor that people thought was most responsible. Global warming is what people felt was least to blame.
The Environmental Agency Flood Risk Managing Team leader of South Yorkshire, Steve Ragg, says the causes of the 2007 floods were the weather fronts, 400 plus millimetres of rain, the jet stream is south of usual, record amounts of rainfall and river levels, high sea temperatures causing a lot of evaporation, causing heavy rain.
This flood risk map shows how at risk each house is from flooding. As you can see, the further away from the river the house is, the less at risk it is from flooding.
Land use sketch. As you can see, the land use is carefully thought about around the River Rother area. Between the River Rother and the nearest set of houses there are 2 roads and an open area, which are much lower in value and easier to repair than houses.
Over half the people we questioned believe that they would expect their home to be flooded in the future. However, this would not be what the EA suggests, as only 12 of these residents are in significant flood risk zones. A lot of people believe that they are at moderate risk of flooding where they are. However, this is untrue, as only 2 people that were questioned live in a moderate risk zone. Only 4 people believe that they were at significant risk from flooding. This could mean that people are unaware that they are at high risk of flooding. This could either be because they have received no information on it, or they chose not to believe it. We worked out the Spearman's rank correlation coefficient for the period of residency against how at risk residents think they are. Because our result was close to 0, it means that there is no correlation and there is no link between the two.
Eyewitness accounts of the floodings. Roy and Manley Hartley were the flood victims. We watched as the flood water ran into our home. We only had time to grab our ferrets and some clean pants.
This map shows how much people thought they were affected by the 2007 summer floods. It matches very closely with the EA's flood risk map. This newspaper showed that environmental impacts of the floods included 1,590 tonnes of debris being swept along by the floodwater, and many habitats were destroyed. Some social impacts were that 3 people died, many were stranded and had to be rescued, and power cuts affected 48,000 homes, whilst an economic impact was that 1,000 businesses were damaged.
These photos show how badly affected Catcliffe was during the 2007 floods. These show that the ground level of all these buildings could not be accessed as it was completely submerged. This photo shows that people had to be evacuated by boats, as the only other alternative was to wade through the water, which the content of was unknown. Many vehicles had to be abandoned where they were due to there being no other way to remove them. This added more figures to the total cost.
Sheffield City Council Flood Recovery Coordinator from Sheffield Council, Linda Lawson, said the impacts were: north of Sheffield was hit worse than the south, roads were 5 to 6 foot underwater, communities were split up, and problems with the insurance companies. The EA website has several flood management strategies: flood defences, development of floodplains, which means no building, catchment flood management, funding from local authorities, and channel maintenance.
Number 47 Orgreave Road and 29 and 30 Old School Lane are all at severe risk of flooding. Both 29 and 30 Old School Lane have similar ideas about the flood wall. This is because they live in the same area, unlike Orgreave Road, and so would be similarly affected. All 3 addresses have similar ideas about the wall and whether it totally stopped flooding. They are mainly sitting on the fence by giving it a 3.
California Drive is highly susceptible to flooding, as some areas are in a severe risk zone, whereas 10 and 14 Old School Lane is in a low risk zone. The residents at 14 Old School Lane thought that the flood wall didn't totally stop flooding. This may be because they were more severely affected than their risk zone led them to believe. However, 10 disagreed and thought that the flood wall didn't totally stop the floods, but helped a little, whereas 30 California Drive sits on the fence and gives it all 3s. Unlike number 14, 10 thinks that flood wall spoils the area. Number 14 edges towards improving the area. All three houses give a similar score for the value for money. This shows that they all must have been affected by the flood.
We have evaluated the methods we used. We looked at the strengths of our strategies and the weaknesses. We also looked into the opportunities and threats of our methods.
Some of the strengths of our methods include we use both stratified and systematic sampling. This means that we were able to sample every flood risk zone, ensuring ground coverage. We also gathered both primary and secondary data. This allows us to compare our results with other people's, for example, to see how much at risk people in Catcliffe actually feel. Also, from areas at most risk, we gathered enough data to produce a statistical analysis.
We did find some weaknesses to our fieldwork methods. For example, even though we collected data from 31 houses, we did not collect a big enough sample. We needed 50 plus answered questionnaires to give a really detailed analysis for our hypotheses.
Obviously, this means that improvements could be made to make our sampling methods more accurate. Some things we could change if we could do this again would be:
Go on a weekend. This could mean more people would be at home rather than at work, giving us a large sample size. We could also have tried posting our questionnaires. This way more people would have filled them in, giving us a greater sample. Our questionnaires could also have been improved. This is because some questions had odd numbers, meaning that people could give the answer of 3. This gave us no results. By changing the numbers to even, we could get more accurate results as we would get more definite answers.
Finally, we looked into the threats that would stop us from improving our sampling methods. One reason could be that people work and we cannot be sure whether or not they will be in or out, even on a weekend. Also, our time limit stopped us from getting as much data as possible, as we could not spend long waiting for people to arrive home. It also meant that the answers we were given had to be short, so we could get around as many houses as possible.
Overall, the rains were a key factor in this flooding event. Global warming too could have played its part, as the polar jet stream was much further south than usual for that time of year. It is not just the physical factors, such as precipitation, it is also human factors, like changing the land, whether that is by building or draining marshland. Overall, it is that Catcliffe is a low-lying settlement. This means that Catcliffe has a greater chance of being flooded, as there is very little to stop it from avoiding this. There are many impacts, and overall these forced people out of their homes and destroyed their properties. This put many people at an inconvenience, as they could not work. Furthermore, some insurance companies did not pay out after the floods, which made it difficult for the occupant that had been affected. There are a few flood management strategies in place, such as a flood wall. Leaving land unbuilt like football pitches, therefore flood waters can flood that area of less economic value. Furthermore, there are pumps to help with the waters. Overall, this could not prevent the flooding, but they could reduce the impacts.